Today what we're going to do is show you how to write equations of lines using the Inspire. So instead of normally doing it by hand, like finding the slope using y minus y over x minus x, and then picking a point along with the slope and using your point slope formula, we're going to show you how you can do this in the calculator. So it would be very handy if you had the calculator with you. So if you're in the classroom, it would be a good idea that you practice this. But the first thing we're going to do on problem 1, it says draw the xy axis. So I think I'm good by putting the, oops, I need to get my colored pencil here. We're going to draw the x-axis here, and I think that's low enough to draw the y-axis because the largest y value is 16. All right, so this is our x-axis, and then this is our y-axis, and we are going to go ahead and put our, if I can get some of this other stuff out of the way. Okay, we need to go ahead and number, let's see, with me writing so big, we're still going to go by ones, but I'm just going to write every other number. So this would be 2 and 4, and then same thing on my y. So 1, 2, and of course this is 0. And 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then what we're going to do is go ahead and plot the points. So here's my 0, 1. And then 1, 4 is right 1 up 4. Right 2 up 7. Right 4 up 13. And then right 5 up 16. Okay, and then we're going to draw our line. All right, so there's our line. And then in order to get the equation, you can probably figure that out on this one, but we want you to practice using the calculator. So right here, you're going to enter, in order to enter the data into the calculator, you're going to go to List and Spreadsheets, arrow up to the top of column A, and rename it X. And then arrow over to column B and rename it Y. And at any part on this, you're probably going to want to repause. You're probably going to want to pause so that you can enter the data into the calculator and go ahead and go through some of these functions. Number 3, enter the data in the appropriate columns. If you want to see the scatter plot right here, you're going to arrow to the top of column A until a column is outlined. Press and hold down Shift and right arrow so that the column B will now be outlined. And then number 2, you're going to press Menu, choose 3 for data, then 9 for quick graphs. If you want to see the equation, which we do, you're going to press Menu, then choose 4 to analyze, 6 for regression, and 1 show linear, which is mx plus b. So if you did that, then your equation would be y equals 3x plus 1. So I told you before that you could have figured this out even by hand because your slope is up 3 over 1, up 3 over 1, and it crosses the y-axis at 1. All right, let's go on down to, one other thing I wanted to go over was right here. Control 6 separates the table and graph into 2 screens. So that's kind of another little tool that you can put in your back pocket as you're working with functions on the calculator. Problem 4 says practice finding the rate of change, which is a slope, for the following table using the table functions. So what you can do is go to the menu, choose 4, statistics, and then 3, linear regression. Click arrow to choose an X for the X list, then choose a Y for the Y list. So if you did that, then you would have gotten an answer of -2. And you could do this by hand even. We taught you to do y minus y over x minus x. So you just take any two y values, dash line, dash, so like -6 minus a -12 becomes a +12, and then -1 minus 2. So you get a +6 over a -3, which gives you a -2. On 5, 6, and 7, it says practice finding an equation that passes through these points using, and it shouldn't say either, it should just say using the calculator function. So go ahead and use the tools that we've taught you in order to write the equation on 5, 6, and 7. So again, you're going to want to practice this and then pause it at any time, but I'm going to go ahead and give you the answers here. So this will be y is equal to 1/3 x plus 5. Number 6, this one is y is equal to 6. And one thing to always observe is if any of the numbers repeat that are in the same location, if it's the y values, then it's y is equal to 6. If it's the x values, then it's going to be x is equal to 1. On scatter plots and line of best fits, or best fit, a graph in which the values of two variables are plotted along two axes, the pattern of the resulting points revealing any correlation presents such a positive, negative, or no correlation at all. Okay, so those are scatter plots. A line of best fit is a straight line that's drawn through the center of a group of data points on a scatter plot. And then it says, which of the following has a more accurate line of best fit? So you just want to make sure that your line goes straight through the set of data. Like you want an equal amount of points on the left side as you do the right side, or above the line as you do below the line. So on problem A, this line is too high because all the points are below the line. Letter B, this line is too low because all the points lie above the line. Letter C looks actually pretty good. There may be a few extra points above the line, but it looks better than the other ones. And then letter D, the line of best fit is drawn the wrong direction. It's drawn vertically. We want the line to go horizontally this way through the set of points. So the correct answer would be letter C. All right, let's go ahead and look over on the back page. And again, you're going to want to use your the calculator, but it says use the data from a graph to create a line of best fit equation, and you're going to use the stat and edit. What you need to make sure that you do first, though, is you have to fill in the table. So it looks like the x are going by 5s, but they just listed every other number. And the y values here, those are gone by 1s. And again, they just listed every other value. So it looks like if we go right 1, okay, which would be 5, and then that would be up 3. And then right 10, up 2, right 15, up 5, 24 is 6, 35 is 8, right 40, up 10, and right 54 is 9. And so this is your table of values. So you can go ahead and use your calculator functions and enter those into the calculator. So you could pause it at this time and do that. And the equation is y is equal to, we're going to round it to the nearest hundredths. So it'll be 0.16x plus 2.03. And then if you draw your line of best fit, it's always good to have a clear straight edge so that you can see that you have about the same number of points above the line as you do below the line. And it is kind of difficult to draw it, but you just do the best that you can. All right, so let's go ahead and take a look at number 9. So on anything like that, where you're dealing with the years, notice it says the years since 2000 right there. So, so the year since 2000 would start with 2001. So we put a 1 there. Don't put 2001. You want the year since 2000. So we're just going to number these 1, 2, 3, 4, 5, and 6. And then, so near 2001, and just do the best you can. We're going to say that this is 28. And then 2002, we're going to say this is about 37. And then 2003 would be 31. 2004, we're going to say is about 48. 2005 is about 51. And then 2006 is going to be about 55. So again, take this time to practice to put this into your calculator. And the answer to the equation is y is equal to 5.54x plus 22.27. All right, let's take a look at problem 10. And this talks about music. So it says the scatter plot shows the number of CDs. Y'all remember what CDs are? In millions that were sold from 1999 to 2005. Use the graph to find the points that will go into the table. So, again, this is year after 98. So if you look at that right there. So that's why we're going to start with 99. So 99, we're just going to say it looks like it's about 930. And then we've got the year 2000. We're going to say that's about 940. Now, if you notice, they have skipped. So it's 1, 2, 5, and 7. So, so they skipped. Let's see. Number 2 was 2000. And so 01 would be 2001. 02 is 2002. 03 is 2003. 04 is 2004. And then 05 is 2005. The thing is that these are gonna, we want the year since 98. And so basically we want to count. So this is like 1, this is 2, 3, 4, 5, 6, 7. Even though those are the years that I've listed underneath there, it should be the years since 98. So 99 is 1 year after 98. 2000 is 2 years after 98. And then 2001 is 3 years. And 2002 is 4 years. So we want to go right here at 5. And it looks like 5 is going to be about 740. And then 7 would be year 2005. And so that looks like it's going to be about 710. Draw a line of best fit through the data, and then you have your linear equation, of course. So you might want to take this time and pause it and go ahead and practice putting this into the calculator. And so now you should have gotten an equation such as negative 42.63x plus 989.89. And I'm going to draw my line of best fit. So I want to make sure I have an equal number of points above the line as I do below the line. And let's go to our last one with the zoo. So it says the table shows the average and maximum longevity of various animals in captivity. So they want us to plot the points. So we've got 1247, so right 12 up 47 is about right there. 2550, so right 25 up 50, be about right there. 1540, so right 15 up 40. 820, so right, these are going to be 10, so right 8 up 20 would be about right there. 3570, 35 and up 70 is right there. 4077, so right 40 and up 77. And 4161, right 41 up 61 is about right there. And then 2054, right 20 up 54 is about right there. All right, so you can go ahead and take the time and put these points into the calculator and see what you come up with for an equation. So you can go ahead and pause it at this time. So we're going to have y equals 1.22x plus 22.45. So we're going to draw the line that best fits this data. Be something kind of like that. When I draw it, I always like to make sure that my y-intercept is pretty comparable to what's in the equation, which is 22.45. So I try to get it as close as I can.